A particle moves along the x-axis so that at any time t is greater than 0, its velocity is given by v of t equals t times ln of t minus t. At time t equals 1, the position of the particle is x of 1 equals 6. Part A says, write an expression for the acceleration of the particle. The acceleration of the particle would be given by taking the derivative of the velocity. So we did the product rule and got t times 1 over t, which gave t over t, plus ln of t minus 1, which ends up being ln of t, when t is greater than 0. B says, for what values of t is the particle moving to the right? To figure this out, the particle moves right when v of t is greater than 0. V of t equals t ln of t minus t, and when that equals 0, it can be simplified to ln of t minus 1. When t is 0, the point is e that you get from solving it. From 0 to e, v of t is less than 0, and from e to t, which is an unknown value, v of t is greater than 0. So the particle moves right when t is greater than e. C says, what is the minimum velocity of the particle? Show the analysis that leads to your conclusion. So to find the minimum velocity, you basically have to set the derivative of v of t equal to 0. And so v of t, the derivative of v of t is ln of t, which we got from part A. And when v prime of t, or a of t, equals 0, then t equals 1. So we graphed it on a number line, and from 0 to 1, it is below the x-axis, or 0. And when from 1 to t, it is above the x-axis. So we know that is an inflection point. So we plugged 1 back into the original v of t and just graphed the equation. This is just the graph of the equation right here. And found that v has an absolute minimum of -1. D says, write an expression for the position x of t of the particle. So if you're writing an expression for the position, you just need to take the integral of the velocity. And so we split it up into two. So the integral of t ln of t dt minus the integral of t dt. And to do this, we used, for the first part, we used the u dv formula. So integral of u dv equals uv minus integral of v du. So our u is ln of t, our du is 1 over t dt, our dv is t dt, and our v is t squared over 2. So we just plug that into the equation, and then for the first part, and for the second part, just solve it like a regular integral. So the t squared over t, or 2, and then plus c, because we don't know the points that we're going to. And then we just simply simplified it, and then we plugged in 1 so we could find c, because that was a known point. And we got c equals 27 over 4. And so we just plugged that into the original equation that we found for x of t, which ends up being t squared over 2 ln of t minus 3/4 t squared plus 27 over 4. Let f of x equal the integral from 0 to x of sine of t squared dt for all x's from 0 to 3. A says, use a trapezoidal rule with 4 equal subdivisions of the closed interval 0 to 1 to approximate f of 1. So the trapezoid rule is just taking the increments and splitting them up into trapezoids so you can approximate the area. The rule is you take the delta x, which is the change in x, divided by 2. So the change in x is 1/4, divided by 2 is 1/8. And then multiply the 25, and 50, and 75 by 2, and add the first term and the last term, which ends up being approximately 0.316. B says, on what intervals is f increasing? So f is increasing when the sine of t squared is positive. So the sine of t squared is greater than 0 when t squared is between 0 and pi, or when it is between 2 pi and 9. So they simplified that, so f could increase from when t, not t squared, but only t, is between 0 and the square root of pi, or when it is between the square root of 2 pi and 3. So the simplified version is the one they went with. So f of x increases on the integral from 0 to pi, or square root of pi, or square root of 2 pi and 3. C asks, if the average rate of change of f on the closed interval from 1 to 3 is k, find the integral from 1 to 3 as sine t squared dt in terms of k. So the average rate of change formula is f of b minus f of a over b minus a. So we just plug that in. So f of 3 minus f of 1 over 3 minus 1 equals the integral from 0 to 3 is sine t squared dt minus the integral from 0 to 1 is sine t squared dt over 2. And that simplified equals the integral from 1 to 3 is sine t squared dt over 2 equals k. And so if we want to get the integral from 1 to 3 is sine t squared dt by itself, you multiply 2 by k, so the integral from 1 to 3 is sine t squared dt equals 2k.